Hey, howdy, hey, folks. It's Mrs. Johnson. I'm in a new location, not my car this time. There is puppies in the house, so if you hear barking, it's them and not me, I promise. Um, Last week I uploaded a video on how to do math operations, and I did not like the way it came out. I uploaded it anyway because I wanted to get something out last week, and then I sat on it. I was like, I can do better than I can explain it better. And so today we're only going to talk about positive movements of numbers, so things that go towards bigger numbers on the number line, um, rather than things that go backwards on the number line, quote unquote, backwards. So addition, multiplication, exponents, because this whole conversation about how math operations works has evolved out of my mini lectures about how exponents work. And so just leave here with the understanding that subtraction, division, and roots of numbers work the opposite way on the number line. They do the same jumps, same things, same movements, as long as they're the equivalent operation. So addition, subtraction, multiplication, division, um, exponents, roots, same thing, move the same way, just on different ways in the number, or different directions in the number line, I should say. So with that preface coming into play, we'll jump into how we move things on the number line. Most people that I've come across in the US, at least, spent the majority of my time in the US, is pretty good on, if not golden, on addition, pretty good, if not golden, on multiplication, and is at least somewhat shaky on exponents. I am a little bit if it's been a minute. I do still make some simple mistakes with exponents because I don't use them often. In agriculture, we use them to conceptualize things like plant growth or livestock growth or revenue growth or business growth. Exponents are a very good way to kind of demonstrate growth that is very, very fast growth. There's other things, other types of growths that happen in agriculture, and we'll look at graphs at some point, hopefully on this channel, and see the differences between graphs in math, because I think it's cool and I think it's useful. But without further ado, we'll jump into these three things. Addition is in the purple, multiplication I'll do in red, and exponents I'll do in green. Again, I apologize if you're colorblind. I tried to make them bright enough colors that they would maybe make a difference in color blindness. So sorry, my bad. Still haven't found a good way to do this, aside from organizing really well and using colors. So my apologies. Addition, I like to tell people, addition is the simplest movement of numbers. It's the easiest way to move numbers around, the most simple, and you are moving in single numbers at a time. So you only add one at a time in addition. 1, 2, and we count in addition when we say 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 100, 101, 102, 103, 104. Kind of get the point. Multiplication is the next biggest movement in numbers, and we move in groups of numbers. And so it is, multiplication is addition done faster. So, right, when we count in multiplication, we count like 2, 4, 6, 8, 3, 9, 12, 15, 10, 20, 30, 40, 5, 10, 15, 20, 25, 50, 100, 150, 200. You kind of get the point. Um, Now, exponents is multiplication done faster. Um, it is groups of numbers, and that might not make a whole lot of sense until we start writing it out. When we count in exponents, we count like 3, 4, 8, 4, 16, um, 3, 9, 81. I think it's 81. Um, and so you see there's massive, massive jumps. The first couple might be kind of small, but then those movements move so much faster as you get further and further into exponents because you're counting in groups of numbers, and you start building bigger and bigger groups. Um, and you start moving in bigger and bigger and bigger in groups. What exactly does those movements look on the number line? Let's talk about it. We'll do addition first and get the simplest movement out of the way. And you see I have some examples written. So 2 plus 3, right? We can tally that. 2 plus 3, right? And we can count those tallies. 1, 2, 3, 4, 5. We have 5 tallies. And we can move like that. When we move in addition, we count the first two numbers, 1, 2, and then we count the next set of added numbers one at a time. So we need 3 single numbers added to 2. And you see that in our tallies. So 2, 1, 2, 3. We get to 5. So we have 5 tallies in total. We have 5 jumps in total. When we do multiplication, you can actually read this multiplication sign has groups of, right? 2 groups of 3, 3 groups of 8, 9 groups of 12, if it's helpful. And I say that because because multiplication is addition done faster, we can write it as addition. And I'm sure if you've been to school in the US, at least, I'm sure you've done this. So two groups of 3, right? And so 3 plus 3, right? 2 groups of 3. 3 plus 3, I know is 6. Now let me demonstrate that in the number line, right? And so rather than doing single jumps, we'll jump 3 at a time. And we need 2 jumps of 3. We start at 0, we go to 3, and then we add 3 more, right? 4, 5, 6. And we jump over there. 2, 6. And we stay there. That's it. And we only needed 2 jumps. Now 2 to the third power, if we jump over to exponents, as I mentioned, exponents is multiplication done faster. And you might be looking at this 2 to the third power and you might be like, I have no idea what I'm looking at. That's okay. We write it pretty much in the same way that we do multiplication. When we revert multiplication back to addition, we write exponents the same way. This top number here, that 3, is the number of groups that we have. And this bottom number tells us what those groups are. So we have 3 groups of 2 multiplied together. 2 times 2 times 2, right? And you might be like, okay, that's kind of simple. 2 times 2 times 2, I can do that. And so let's do it in the math first because, it can be kind of easy to be like, oh yeah, that's just all straight multiplication. We work left to right using order of operations. If you want to look on order of operations, if you're a little shaky on it. So 2 times 2 is 4. And then we bring the rest of our equation down, which is that last times 2. 4 times 2 is 8. Now, how exactly do we write that on the number line? We write that on the number line the same way we solved it in our math. So 2 times 2, we have to do those two jumps first, or that jump first. We have two groups of 2, right? So we start at 0, we jump to 2, and then we jump to 4, 2 groups of 2, and then we solved that, right? That's all done. We did that jump. Now our equation is 4 times 2, 4 groups of 2. Now you can either do 2 more jumps or you can do a jump of 4, right? 4 groups of 2, right? Now you'll notice that we didn't actually use that 6. So some people will just jump straight to 4 or make that solid jump to 8 because that's the nature of exponents. Each jump doubles in size, essentially. So we have 8. That might not make a whole lot of sense. We will do a few more examples without the number line in exponents because exponents can be tricky. So we're going to come down here and do these examples and write them out in multiplication just to make it a little easier. I've noticed that makes life easier for people when they're first learning exponents. Makes it conceptualize a bit better. Now, what I will do, actually, is I will write here an example, because I didn't do that earlier. And we will go number used on the bottom, right? Because our bottom number in exponents is the number we use, and that top number that goes up here in superscript is the number of groups. Apologize for the bad writing. Right? Number used, number of groups. So now that we have that little reminder, if I can get my digital whiteboard to behave. Right? I'll box this whole thing just so then we know it's a reminder for exponents. We'll start with this first one, the 3 to the second power. And so 3 is used, right? If we use our example, 3 is used, and we multiply it. How many times? 2 times. So 3 times 3, right? 3 to the second power is equal to 3 times 3. 3 times 3 is 9. You can use a calculator. I'm never gonna not tell you to use a calculator. I will tell you to show your work. So as long as you show your work on your paper, you can use a calculator. You stop showing your work and just use the calculator. I'm like, cool, dude. I need more information. Now, 5 times 3, right? Let's write it out. The number we use is the bottom number. We have 5. We need 3 groups of 5 because it's 5 to the third power. 5 times 5 times 5. Now, this one is a little tricky to a degree because it's bigger numbers. And you'll see that this grows exponentially. 5 times 5 is 25. We bring the rest of the equation down. So 25 times 5, I know is 125 because I'm in the US and we use US currency, quarter. One of our coins here is 25 cents. When you have 5 quarters, you have $1.25. So 1, 2, 5, right? 25 times 5 is $1.25. 125. So 5, third power, is 125. And you see that we started 5, 25, 125. Now 1 to the fourth power, I added these because they're these last two because they're concept pieces. They're things that your math teacher would probably throw at you and be like, ha, trick question, right? But let's do the math. 1 to the fourth power. We use the number 1, right? 1, and we have 4 groups of 1 multiplied together. 4 ones, right? And then we just solve it the same way. 1 times 1 is 1. Bring the rest of the equation down, right? 1 times 1 is 1. Bring that last times 1 down. 1 times 1, 1, right? So when you don't go anywhere and you multiply 1 by itself. You have one group of 1, one group of 1, one group of 1. Does that make sense? Because you only ever stay with one group of 1 when you multiply 1 times 1 together. One group of 1. Now, what happens if we have the inverse of that? So if we use the number 4 and we only have one group, we don't multiply. 4 to the first power is 4 because we have one group of 4 multiplied. One group of 4 multiplied is 4, right? And that makes sense, right, on the number line, because if you only have one group and you move that one group of 4, you've done it. You've got one group of 4. You don't need any more, you don't need any less. And so I hope this helps. If this is a bit easier of an explanation than my last video, I will preface with the fact that these are all positive numbers and positive movements of numbers, and the negative movements of numbers move in the exact same way, just backwards. They move the other way on the number. So if we come up here, right, to the single numbers added, groups of numbers added, groups of numbers added, right? Same thing, you would just take them away. When you subtract, divide, use roots. I will show you what roots look like. Roots are the funny things that look like this. Sometimes they have a number right here. And this number right here is the same thing as it is in exponents. It's the number of groups that you make it smaller by. And this is the number you use to start making it smaller. Once you get the hang of it, it's pretty easy to practice and get better and better. But if you're out of practice, it does take a minute to get back into exponents and getting them done correctly. So hopefully this video helped better than my last video. Thank you for listening. I hope you have a lovely day. And I hope to see you soon.